The study of stem cell is an important area in biology, as a cell that has essential properties such as the ability of regeneration, factors that impact the development need to be researched. While it is harder for scientists to look at stem cells in more advanced and complex species, planarians are a great model species to look at because of its strong ability of regeneration. For example, irradiation of UV light can effectively eliminate neuroblasts because UV radiation causes major damage to microtubules in DNA, which are two important components in the process of mitosis. Thus, when mitosis cannot be performed, the neuroblasts are not able to function in the process of regeneration. We hypothesize that different wavelengths of irradiation could cause different effects on planarian regeneration. We create one animal care protocol for our planarians, which includes housing, temperature, food, light, and post-experiment plan for the animals. Part 1 of the lab is to irradiate the planarians. This part of the experiment took place in a dark room to decrease the effect of natural light on the planarians that will be irradiated in the next steps. The planarians are separated into different petri dishes as grouped in the table below. The petri dishes containing the planarians were put underneath the UV lamps / the blue light or the red light. So, for the UVA and UVB light source, the planarians are put 30 centimeters away from the lamp, and for the blue and red LED lights, the light were put as focused on the planarians as possible. So this decision was made because of the different wavelengths and light intensities of the different devices. In order to look at the lengths of radiation on the planarians, each light group were divided into two different light groups to look at separately. One is the 5-minute group and one is the 10-minute group. The second part of the experiment is the surgery of the planarians. Each individual planaria had the same protocol in this part and received the same surgery. The planaria was transferred into an empty plastic petri dish, and then we used scalpel blades to cut the planaria transversely into anterior and posterior halves. Thirdly, we use a transfer pipette and gently transfer the head and tail of each transected planaria into separated wells of label cells culture cluster in containing natural spring water. And after all these steps, all planarians were left in the incubator set from 21 to 23 Celsius in the dark. Due to the limited amount of time of our experiment, we weren't really able to draw a conclusion of our experiment. However, we did have some really general observations of our lab. For example, even though none of our planarians has fully regenerated, we were able to see some tissue regeneration process in our videos, in our pictures, in our daily observation. Secondly, we were able to observe that most of the anterior halves of the planarians appear to be more active than the posterior halves of the planarians. Due to the limit of time, we weren't able to draw a conclusion if different wavelengths would make the regeneration process longer or shorter after irradiation. However, we could conclude that intense radiation of shorter wavelengths could lead to the death of the planarians right after being exposed under the light. Consequently, longer wavelengths tend to have a milder effects on planaria right after exposure.